In this video, we'll be looking at finite geometric series. In the last video, we looked at arithmetic series. So this video will be finite, and next video will be infinite geometric series. So the sum of the terms of a geometric sequence is known as a geometric series. So we take all of the terms from a sequence, add them all up, and that gives us the geometric series. So the sum of a finite geometric series, sum of the first n terms, is given by this formula where r cannot equal 1. If r is 1, then you're just multiplying by 1 every time and it wouldn't change for one thing, and then also we would make the denominator 0 here if we had a 1 right there. Alright, so example 1, find the sum of the first 12 terms of this geometric series. So in our formula we need two things, actually three. We need a sub 1, well that's 3, it's given right here, that's our first term. We need r, and we can find r by taking one term and dividing it by the one before it. So we could take that one, divide it by that one, and you can clearly see we're multiplying by 2 every time. So the r value there is 2, and then we need the n value that goes right here, and that would be 12 because we're summing the first 12 terms. So we just plug that into the formula, and we get a sub 1, 3 times the quantity, 1 minus 2 to the 12th, all over 1 minus the r value of 2. So at this point, we put that in our calculator and move this over here so we can see it, and we'll get our answer. So in this case, I'm going to use my fraction button just to make it easy here. So 1 minus 2 to the 12th in the numerator and 1 subtract 2 in the denominator. So that would be 12,285 is our answer there. So that is it for example 1. Okay, now for example 2, find the sum of the first 11 terms of the geometric series where the nth term is defined by this rule here. So here's our formula for our geometric series, finite geometric series. So we need three things. We need a sub 1, and that would be this negative 4. We know that because they're showing us the pattern here. So a sub 1 is negative 4. We need our r value. Well, in the pattern, that would be right there, the 3. So our r value, common ratio, is 3 there. And then our n value would be 11 because we're finding the first 11 terms. So we just fill in the formula, and that sum would be s sub 11 in this case is equal to a sub 1, negative 4, times the quantity, 1 minus our common ratio, 3 raised to the 11th power, all over 1 subtract 3. So put that in our calculator here, negative 4, use that fraction button again here, and that's not what I wanted, negative 4 times, now use the fraction button, and 1 subtract 3 to the 11th in the numerator, and 1 subtract 3 in the denominator. Negative 354,292 is our answer for example 2. Okay, now for example 3, find the sum given by our sigma notation here. Using the S sub n formula, to make this fit the standard formulas in which the indices start with 1, adjust the indices. So we need our a sub 1 value here for our formula. That's what they're talking about. So we're starting with negative 1 though, so we need that actual first term starting with an index value of negative 1. So the original a sub negative 1 is equal to negative 2 times decimal 6 raised to the negative 1 power. We're just plugging in a negative 1 there for the j value in this case. So that would be equal to negative 2 divided by 0.6 because we're raising 0.6 to the negative 1 power. So we move that down into the denominator and make the exponent positive. Exponent of 1 is not needed there to be listed. So our adjustment has to be making this a sub 1. So we're actually adding, I'll write it, we're adding 2. We add 2 to get to that index value. So that means we need to add 2 to this, and our a sub 15 original becomes our a sub 17. So our n value here is actually going to be 17 as a result of that. Okay, because we have to make the adjustment to the indices. We're starting at -1 originally. We have to adjust that so that we start with 1. So we add 2 there, so we have to add 2 here. We're adding 2 to that number to get this n value. Okay, our r value is pretty straightforward. This is our geometric sequence rule here, and we have the 0.6 there is raised to the exponential, has the exponent there, so that is our r value. Whatever is raised to the exponent is your r value in your pattern. So r equals 0.6, so we fill it in. So we have -2 divided by decimal 6, that's this a sub 1, times the quantity 1 minus our r value, decimal 6, raised to the 17th power, because that was our n value. Remember, we took this, we had to add 2 after our adjustment, and our denominator would be 1 minus decimal 6. So I'm going to put that part in parentheses here, and then I'm going to use our fraction button, and that's not what I wanted, so let's try that again. Let's use the fraction button twice, why not? -2 over 0.6, and then times, now fraction button again, and we have 1 minus 0.6 raised to the 17th, all over 1 minus decimal 6, and that gives us negative, we'll round to 2 places, negative, actually we'll round to 3, negative 8.332 is our answer there. So that series, that finite geometric series, would be negative 8.332. Okay, example 4. So they give us some instructions here on how to put this sigma notation in our calculator, but this is a little outdated on your assignment the way it's listed. With a newer operating system on your TI-84, it's actually easier than that. So we're going to mark that out, and here's how you get to it. Math, and then it is option 0, summation here, option 0, and we are going to use, in this case they're using k, so from k equals -2, arrow up here to 8, and our rule is, I'm going to use a fraction button here, 1 over alpha k, where's our k at? There it is, k squared plus 2, and hit enter, and it gives us the answer 1.74 rounded 5, 1.745. Alright, so again, going through those steps, we went to math, we went to option 0, you could just type in 0 right here and then fill it in. So with the math print updated operating system on your calculator, it's much easier than going through the steps they listed. Okay, that's it for example 4, and that is it for this video.